In this recording or in this video, I will be solving systems of equations. We're going to look at basically 3 different types of systems, and we're all using substitution to solve these every time. So substitution, remember, is the process of taking one variable or the expression or number that that variable equals and plugging it in, substituting it in to the other equation. That way we have only one variable in the remaining equation to solve for. So remember, any system of equations, we're looking for an x and a y as the solution. Remember, when we graph systems of equations, we're looking for that point of intersection that meets both constraints, okay? So we want an x value and a y value that works both for the first equation and the second one. Well, if you notice in this problem, we're pretty lucky because it already tells us that y equals 4. So the first half, essentially, of my answer is already done. So I know that y equals 4, like it gives that to me in the original problem. So I can take that information and substitute that 4 in for y right here. So I'm going to rewrite my second equation, except instead of y, I'm going to replace that y with a 4. So my second equation would then say x equals -5 times 4, because 5y would be 5 times y, and then plus 6. Well, now I have x isolated on the left-hand side, and I just have numbers on the right that I can simplify. So I'd take -5 times 4, multiply those together, -20 plus 6, and it's still equal to x. And then again, I'm just continuing to simplify. So x is going to equal -20 plus 6, which would be -14. And that's my answer. So what I can do is I can actually take these values, plug them back into my original equations, and see if I get a true statement, right? So very quickly showing you that. So if I plug -14 in for x equals -5 times 4 plus 6. So just quickly, I do in fact get a true statement. I got the right answer. So x would be -14 and y is equal to -4. So that's the first type of system where one of the variables is given to us as a numerical value. Okay, if I'm looking at this second type of system, I have y equals -3x plus 10 and y equals -2x plus 6. Again, my ultimate goal is to get what y equals and what x equals, right? I need that coordinate point, that xy coordinate point. So the issue here is that it doesn't tell me that x equals a number or y equals a number like it did in the previous problem. It does tell me, however, that y equals this expression, this -3x plus 10, and y also equals this -2x plus 6. So I can do substitution, but instead of substituting a number into the equation, I'm going to substitute an entire expression in for this variable. So I'm taking this -3x plus 10 and I'm substituting it in here for y, just like we talked about in class. Nothing else about our equation is going to change. I'm just replacing this y with this entire expression. So rewriting that would look like -3x plus 10 equals -2x plus 6. Notice that that -2x plus 6 on the right-hand side didn't change. The only thing that changed was that y value becoming that -3x plus 10. So now what I need to do is I need to solve for x. So this one has a few more steps to it. I'm going to start by kind of getting all of my like terms together on the separate sides of the equations. So I'm going to start by subtracting 6 from both sides. Add 3x, right? Showing my work here, trying to get all of the numbers on one side of the equation, all the variable on the other. So I'm getting x to equal 4. So I can put that up there. Well, as you can see, I still do not know the y value that I need. So I need to go back and find out what that y value is. How do I do that? Well, I know that y equals -3 times x plus 10, and I know that x is 4. So I can take that x equals 4 and substitute it in. Sorry, hold on, look at my paper here. I'm substituting what I know x to be into that equation. So y equals -3 times x, and remember x is 4, plus 10. And then I'm just going to simplify here. So y equals, this would be -12 plus 10. Y equals -2. And again, you can check your work by plugging both of those values in to one of the equations, and you should get a true statement. If you don't get a true statement, something went wrong. Okay, let's look at one more type of system. Okay, so I would say it's actually more similar to the second equation that we just did, the second system, because it also does not tell us what x equals or what y equals right off the bat, unfortunately, like that first system did, which was so nice. So we're going to have to do a little bit of, we're going to have to substitute here. And I'm looking at this second equation because it tells me that x equals 2y. Like whatever y might be, I'm going to multiply it by 2, and that's going to give me what x is. So again, I can take this entire expression that equals x and substitute it into the first equation for x. So every time I see x, I'm going to replace it with a 2y. So rewriting that first equation would look like 3 times x. And remember, x is really now 2y plus 4y equals 10. And then I have this equation that I need to solve for y. So I'd have 3 times 2y, which is 6y, plus that 4y didn't change, and neither did that equals 10, right? The rest of my equation stayed the same. The only part that changed was I replaced x with 2y, and then I simplified that part of the equation. Now I'm going to solve for y. I'm going to add these two like terms together. So that's 10y equals 10. Then I will divide by 10 on both sides to get that y completely isolated, and y is equal to 1. So I know y is 1. Then I need to go back and find x, okay? And you can use either the first equation or the second one to find the remaining variable. I'm going to use the second one because it's smaller. It has less work for me. So x equals 2y, and I know y to be 1 from my work here. So I would have x equals 2. And again, to check my work, we would plug in those values here for x and y and see if they would equal 10. So quickly, let's just go over that. So 3 times 2 plus 4 times 1 equals 10. So that'd be 6 plus 4, 10 equals 10. It worked out. We got a true statement. So I know that that is the correct solution, okay? If I get something here that says like 12 equals 10, then I know something went wrong.